Okay, everybody, let's recap the day. So first of all, we went back and talked a little bit about what we call interval notation, all right? So I went back and talked a little bit about something we learned maybe in geometry, but let's start with this line segment, okay? So I've got a line segment on the number line, and I put a solid dot at -4, and I shaded everything up to 6, okay? So my solution is all of the values in between -4 and 6. So what we could do is we could write that in inequalities. As an inequality, we could write it as -4 is less than or equal to x, which is less than 6, which, again, if you read this backwards, there's x is greater than or equal to -4, true, or x is less than 6, but not including. Okay, great. Then we had this new one called interval notation. Interval notation you're going to use a lot in calculus, so we have to learn it. If we have a bracket, it means it includes it. So the interval notation means we're looking at an interval between -4 and 6. We have an interval between -4 and 6. Yes, we do. We include -4, bracket, solid dot, parentheses. 6 is not part of our solution, so parentheses means we do not include 6, or it's an open dot, okay? Set notation is a little bit more complicated. Sometimes set notation works real well, but it's a little bit difficult. But set notation uses set symbols. It's like the set of x, and then this means such that x is greater than or equal to -4, and x is less than 6. Okay, so there's 3 different ways to describe it. Now, what we've been dealing with are graphs like this. So an example, this could be f of x equals 1 over x minus 3. And we know that x cannot equal 3. So that's why you have an asymptote here. So in interval notation, interval notation, and this is where we want to get to, we can say that the interval's from -infinity to 3, but not including 3, and it's also from 3 to infinity. Now I want to take inclusion both. I want to just make sure I have this half of the graph and this half of the graph. So it's a union. I'm recording for a little bit, so go ahead. Yeah.
Okay. Sorry to barge in there.
No, that's okay. I always try and wrap up the lesson, record it at the end of the day, and post it. Yeah.
Oh, yeah. Okay. Just real quick, how's Addie Castaneda doing for you in Avid?
Can I talk to you later about that? Because it's going to be live. Okay.
Oh, sure.
Can I talk to you about that as soon as I get done? Okay.
Yeah, absolutely.
I'll come down and see you. Okay.
Yeah, that's
because I don't want to record that, right?
Yeah, no, that makes sense. Yeah,
right.
You're mid-recording.
Yeah, and post it to all the kids. Yeah, I'll be there.
Yeah, no worries.
Okay. All right. And then, sorry about that interruption, everybody. So then we talked about reciprocal functions. A reciprocal is like the upside down. So we started with x squared. X squared can also be written as 1 over x. If we upside down that, we wind up with 1 over x squared. So the reciprocal of 1 over x is of x squared over 1 is 1 over x squared. And we graphed this on Desmos, and we saw that it looked a little bit like this. Let me see if I can show you in Desmos. Back it up, over, back, squared. Looks like this. So as reciprocal, everything is the opposite. Where the blue graph gets big, that's my x squared. The reciprocal gets small. Where the blue graph gets big, the reciprocal gets small. Right at 0, x is 0 here, but 1 over 0 is undefined, and that's why you have an asymptote, okay? So on this graph, we have a vertical asymptote at x equals 0, and we have a horizontal asymptote at 0. Domain, if I do interval notation, being from -infinity to 0, union from 0 to infinity. Domain range, we could say is from 0, not including 0, and up to infinity. Okay, now we turn the page, and if we plugged all of these values in to x squared and into 1 over x squared, we get these values into x squared, and we get its reciprocal values we plugged into 1 over x squared. So we get 1/25th, 1/16th, 1/9th, 1/4, 1. And if I plugged in these values into x squared, I would get 1, 4, 9, 16, and then I'd get the reciprocal. One of the things I notice is that they're all positive because I'm squaring a negative, okay? So if I graph x squared and 1 over x squared, sure enough, that's the graph we have, okay? Now, we know, again, we talked about domain and range is all real numbers except 0, but we can use interval notation also, okay? And then finally, we talked about if you have 1 over x to an even power, it will always look like this. If you have 1 over x to a odd power, it will always look like this, okay? And that's what I had for the lesson. I will be right back. Thank you. See you tomorrow.